Hello and welcome back to another Walking Talking mock. This is C3, January 2006. So this is old spec A2 from MEI. We're going to do section A in this video and we're going to do section B in the next one. So, question 1. Given that y equals that, show that dy by dx is that. 4 marks. Okay. So y equals 1 plus 6x to the power of a third. Okay, so we're going to use chain rule here. Either the quick chain rule or the slow one with the let u equals. I'm going to do the quick one. So bl to the power of a third would become a third bl to the power of minus a third, and then I have to times that by the derivative of the bl, so that is 6. Okay. A third times 6 is 2, so I've got 2 times 1 plus 6x to the minus third, which I could write as 2 over 1 plus 6x to the third. And the question specifically wanted me to notice that this is equal to 2 over y squared. Well, okay, I made a mistake. A third, take away a third. No, I mean a third, take away 1 is minus 2/3, isn't it? Oopsie. That's better. Okay, and do you notice that 1 plus 6x to the power of 2/3 is the same as y squared, because it's the same as y but there's a 2 in the power. So I just want to make it really clear to the examiner that I'm not just like hand waving this. I want them to know that I actually do understand that that's that squared, because I don't want there to be any doubt that I deserve the marks. So there we go. That is question 1. Let me check the mark scheme. M1 for chain rule. B1 for a third of something to the minus 2/3. Accuracy 1 for any correct expression. So basically A1 for that in any kind of form, and then E1 for ending up with the answer that they gave you in the question. Okay. Question 2. A population is p million at time t years. We've got an equation for it. A and b are constants. They've given us the initial and after 1 year. Use this information to calculate the values of a and b for 5 marks. Okay, so we've got p equals 5 plus a e to the minus bt. Okay, so it says initial population is 8 million. So 8 equals 5 plus a e to the minus bt. So 3 equals a e to the minus b. Oh, sorry. Initial means t is 0, so I can put 0 in there. So it's like that. E to the power of 0 is obviously 1, so a would have to be 3. Okay, and then it also told us declines to 6 million after 1 year. So after 1 year, 6 million. 6 equals 5 plus, I know that a is 3 now, so I can put that in there. And t is 1, so it would just be minus b. Take away the 5. Divide by the 3. So log of a third is going to equal minus b. So b equals minus log of a third. which, by the way, is the same as log 3, because if I move the minus up here to become a power, then I've got a third to the minus 1, which is 3. It says giving b correct to 3 significant figures, so I'm not going to write it as log 3. I'm going to actually find the decimal, which is 1.09, 3 significant figures, 1.10, that would be. Okay, so I found A and B, and then what is the long-term population predicted by the model? I can do that on here actually. Long-term. So the long-term would be if t got really, really, really big. So let me have a look at the equation now that we know the A and the B. Okay, so let's think if t, that's right, as t tends to infinity, so as t gets really, really, really big, e to the power of minus a really, really big number, e to the power of a negative really big number, that would be really small, right? E to the negative power of something, it gets smaller, doesn't it? Okay, so really, really, really small. So 3 times something really, really small is basically still nothing. Yeah. So I've just got 5 plus something really small. So p would actually tend towards 5. So the long-term population would be 5 million. Because this bit is decreasing towards 0, and the 5 would be all that remains. And if you wanted to test this out for yourself, you can say like, okay, let's say that t is a really big number, like, what's a really big number? 1 million. The answer is 5, according to my calculator. The answer is, of course, not exactly 5, it's 5.00000, but the zeros are so, like, there's so many of them that it's just going to round to 5. So, yeah, that's one way of testing it out. If the idea of thinking about limits and tending and all of this is too difficult for you, just shove a really big number in, and we are cool. Okay, mark scheme. M1 for substituting t equals 0. A1 for getting that A is 3. M1 for this equation. A1 for B. Oh, sorry, I missed out on M1. That when you take logs, that's, oops, sorry. Sorry. Yeah, you get an extra M1 when you take logs. And then you get a B1 for the 5 million, which doesn't require any working out or evidence that you know what you're talking about, because it's a basic mark. And what was I going to say? Either write 5 million or write p equals 5. They'll accept both. They shouldn't accept p equals 5, really, but yeah. But they do. I feel like I was going to say something about something else here. What was it? Never mind. Oh, that was it. This one is a follow through. So if you got A wrong, you can still get the accuracy mark for B. Okay. Question 3. Express 2 log x plus log 3 as a single logarithm. Okay. At the moment I can't use the addition product rule because the 2 is in the way. So you first have to change it into a power. Okay, always do the power bit first. And now I can combine it into one product like that. And notice that this is not the same as 2 log 3x. Okay, because the 2 is only applying to the x, the 2 is not applying to the 3. So I couldn't do that. I could write 2 log root 3x, that would be okay. I mean, don't do that, that's silly, but that would be equivalent. Part 2. Hence, given that x satisfies the equation that, show that x is a root of the quadratic equation, blah, blah, blah. Okay, so if 2 log x plus log 3 equals log of 5x plus 2, and we know that that implies log of 3x squared equals log of 5x plus 2 from part A. Which means that we can just you can just unlog both sides. That's not an issue. And then we can make this into a nice quadratic format. Like that. Didn't ask us to find it, it just said show that it makes that. And then part 3 is solve it and explain why there's only one valid solution. Okay, so we're going to solve it. Will it factorise? I bet it will. 3 times 2 and 1, yeah, 2 and 1, minus 6 plus 1. Okay, so we've got x equals minus 1/3, and we've got x equals 2. Okay, only one of these solutions is valid, and why is that? Let's look at our original equation. We've got 2 log x plus log 3 equals log 5x plus 2. If I substituted x equals minus 1/3 into this equation, would it satisfy it? The answer is no, because I can't do 2 log of minus 1/3. Log of minus 1/3 does not exist. You can't do the log of a negative number, because that's like saying e to the power of something equals minus 1/3. Well, there's no way that you're going to get e to the power of something to equal minus 1/3, because the power on the e can't turn e negative. It can only make it bigger or smaller, but it can't make it negative. So, not valid as log of minus 1/3, not possible. Something like that. Okay, so now let's get the mark scheme. So, part 1, we're going to get B1, just for that. We're going to get, 2 B marks for this. We're going to get a B1 for moving the power, and B1 for doing the product. We're going to get M1 for anti-logging. That's what the mark scheme says, it says anti-logging. Factorising, wait, no, I missed out E1. E1 for getting the answer they gave you. M1 for either factorising or using the quadratic equation, or, you could even use your calculator to get that answer. And accuracy 1 for those 2 answers. Correct answer only. And then B1 for this comment here. And it says the B1 is also follow through, not also, but it's follow through if you ended up with 1 positive and 1 negative root. Obviously, if you ended up with 2 positive roots, you can't make this comment. It doesn't make sense. And if you ended up with 2 negative roots, it also wouldn't work, because you'd be saying there's no solutions, and the question clearly said there's 1. So Question 4. Yes, we all remember this question. We've got a cone. The angle between the axis and the slant edge is 30 degrees. Oh, I was thinking of the 45-degree one. Oh well, it's the same. It's basically the same. Water is poured into the cone at a constant rate of 2... I'm just going to jot some stuff down as I read this. Okay. Water is poured into the cone at a constant rate of 2 centimeters cubed per second. Okay. If the water... What is water? Water is like volume. So the rate of the water going in is dV by dt. And that's a constant rate of 2 centimeters cubed per second. So I'm jotting that down just because the question mentioned it. At time t seconds, the radius of the water surface is r and the volume is v. Okay. Part 1, write down the value of dV by dt. Okay, I did that. Already. Show that v equals this and find dV by dr. You may assume that the volume of a cone... Thank you for giving me the formula, because, yeah, I might not have known that. Third pi r squared h. Yeah, they'll always give you those kind of formulas in your exam, because they know that you've forgotten everything in GCSE. Okay. Now this has got r and h in it, but we want something that only has r in it. But that's okay, because we can use the 30 degrees to help us here. Okay, because r and h are related by a right angled triangle. Like that. So I can just use some SOHCAHTOA. Okay, so I know that, do a bit of tan here. I know that tan of 30 equals opposite over adjacent, so r over h. Tan of 30, by the way, is, I want to say, root 3. No, it's 1 over root 3. It's 1 over root 3. Okay, which equals r over h. So what am I trying to replace? I'm trying to replace the h. So h equals, times both sides by, okay, root 3 r. There we go. So now I can put that into there. A third pi r squared root 3r, which is root 3 over 3 pi r cubed, which was what we wanted. And then find dV by dr. Okay, so now I just got to differentiate this. So that's root 3 pi r squared. Okay. Done that. Okay. Use the results of part 1 and 2 to find the value of dr by dt when r equals 2. Okay. Dr by dt. So what I've got is I've got dV by dr and I've got dV by dt. And I want to use those two to get this one. So how am I going to do that? I need the dr to be on the top. Okay, so if I flip that one over, okay, so it's dr by dv times dV by dt, then those two will cancel, and that will give me dr by dt. That's what I need, isn't it? I need to flip that one. Okay, so dr by dt equals, where's dr by dv? Okay, dV by dr is that, so I'm going to reciprocal that because I need it to be upside down version of it. And then I've got dV by dt was 2. So then I'll just sort of simplify that. And then it said at r equals 2. So I just need to put 2 in there. So that will cancel 2 root 3 pi. 1 over 2 root 3 pi. I should put some units, probably, what is this? dr by dt. So radius per second. So centimetres per second. Okay, mark scheme. Let me find it. Okay. B1 for that. M1 for the relationship between R and H. Okay. E1 for getting the answer, because it was given in the question. B1 for differentiating. M1 for working out a kind of chain rule. M1 for substituting the 2 in. And A1, ooh. Yeah, A1. For a moment I thought I wouldn't get the mark because I didn't put it as a decimal, but it does say 1 over 2 root 3 pi or 0.092 centimetres per second. So, yeah, this is like a scientific-y question, so I probably should have made it a decimal. But, I don't know, this answer just looked nice to me. But it's okay, I'll get the mark either way. It doesn't say whether you have to have your units there to get the mark. It's not specific. I don't think they would punish you for that. I don't think. But, you know, try and put units. We've been telling you since year 7 to put units, so. Question 5. A curve is defined implicitly by this equation. Show that dy by dx is that. Okay. So. Y cubed equals 2xy plus x squared. Okay, let's differentiate this. Differentiate with respect to x. 3y squared dy by dx equals 2y, that's with me thinking of it in terms of x, okay. Now let me think of it in terms of y. It'd be 2x dy by dx. Okay, plus 2x. Okay, now I've got to sort of rearrange that. Let's gather together all the dy by dx's. So I'll subtract that one. Leave those 2 over there. Factorise the dy by dx out. And then divide through. And then hope that that's the answer in the question. Okay, just factorise that. And we are good. Okay, hence write down dx, hence write down dx by dy in terms of x and y. Oh, that's easy. I just flip it. Why would they ask me something so easy? I'm suspicious. And just flip it. Well, it's only worth 1 mark, so fair enough. Okay, mark scheme. B1 for getting the 3y squared dy by dx. Okay, so B1 for this left-hand side. Oops, should have attributed it to that one. Okay, B1 for the 2x dy by dx plus 2y plus 2x. So B1 for the right-hand side, basically. M1 for collecting the dy by dx's on one side. So that's that line, really. And then E1 for the answer, because that was given. And then B1, correct answer only for that. Now, that should not be a correct answer only mark, because... Oh, wait, no, it's fine, because the answer was given in the question. I was going to say, if you got the previous part wrong and you flipped it, like, you should deserve the mark. But yeah, it's because the question gave you the answer for that, so fair enough. Question 6. The function f of x is defined by that. Show that inverse is that and state the domain. Okay, so f of x is 1 plus 2 sine x, and the domain is between half of pi and negative half pi and half pi. Inverse, okay. So to find the inverse, I'm going to write y equals 1 plus 2 sine x, and then I'm going to write, I'm swapping the y and the x around. So x equals 1 plus 2 sine y. So now I've got to make y the subject. So I'll inverse sine it. I should probably write arc sine. Like that. Oh yeah, they gave us the answer. And state the domain. Okay, well the domain of this is the range of this. So let me just write down what the range of this was. Let's think. Between pi and half... What does sine look like again? Whoops, that's cos. Just kidding, guys. Just kidding. Okay, it looks like that, doesn't it? I mean, oh my gosh. It looks like that. Okay. So I can see from my little picture, which, you know what, let's draw it again, because that's rubbish. Okay, I can see from my little picture that the maximum is 1 and the minimum is -1. Which, okay, sounds like it's obvious because it's sine, but it depends on the domain. But this is not right because I forgot that I need to times it by 2 and add 1. So -1 times 2 is -2, add 1 is -1. Good. Okay, 1 times 2 is 2, add 1 is 3. So the range of this function will be that. So that means the domain of this function will be the same. Where are we? Oh, now we've got a picture of them. Write down the coordinates of points A, B and C. Okay. Let's just draw it on here, I guess. So, A, so this is f of x. So A is like the rightmost point of f of x. So the x coordinate has to be half of pi. Okay. Right here. It's got to be half of pi. And the y coordinate, we already worked that out, is going to be 3. Okay, now if you look at C, which I'm doing next, because C is like the equivalent point, but in the inverse function. So it's like the reflection in y equals x, which means that the x coordinate and y coordinate will be the opposite. So that'll be that. And then B is where F inverse cuts the x-axis, or you could say it's where it's kind of like the opposite of where A cuts the y-axis. I mean, not A, F of x cuts the y-axis. I know that F of x cuts the y-axis at 1, so if that's 1, then that is also 1. So that's 1, 0. Okay. Mark scheme. Part 1, M1 for doing the switcheroo. A1 for getting to this point. And then E1 for getting the answer that they gave you. B1 for the domain. And then we're going to get B1 for A and B. And C is also a B1, but it's a follow through on A. So if you got A wrong, but your C is the swapping, there's not a word for that, the swapped version of A, then you'll get the mark for C because your intention was correct. Okay, and that is the end of section A. So thank you very much for watching, and section B will be here very soon. See you next time. Bye.